Hello students, and now we are going to see the first question in exercise 9.2. Evaluate the following integrals as the limits of sums. Okay, we have two subdivisions. We'll do it one by one. So now I am going to do the first subdivision. That is the given. Let us write the given. So that is integral 0 to 1 5x plus 4 into dx. Okay, so this is the given integration. So here look at the limits. The lower limit is 0, upper limit is 1. So therefore we are using this formula. Integral 0 to 1 f of x dx is equal to limit n tends to infinity 1 by n summation r is equal to 1 to n f of r by n. So we are using this formula. From this, what is f of x? So f of x can be written as just refer this integral and this integral. So what is f of x? That is equal to 5x plus 4. Okay, so in order to evaluate this integral, we should know the sum of this. Okay, so we should know f of r by n. So what is f of r by n? So r by n is equal to 5 into r by n plus 4. Okay, so in order to evaluate this integral, we should know this f of r by n, and then after we got this f of r by n, we should apply that summation. Okay, so now we shall apply the summation r is equal to 1 to n f of r by n. Okay, that is equal to summation r is equal to 1 to n. We'll use the summation for all the terms. 5 into r by n plus 4. Okay, summation for all these two terms, and then we are taking the sum to each term. So that is summation r is equal to 1 to n 5 into r by n plus summation r is equal to 1 to n 4 into 4. Okay, and now we can take 5 outside. We can take 5 by n outside, because we'll be using this sum only for r. Okay, so we can take 5 by n outside. So we'll take 5 by n. So summation r is equal to 1 to n r. Okay, plus, and here if you apply the summation, you are having n terms. Okay, if you put r is equal to 1 to n, you are having n terms. So simply you put 4n. Okay, because you are having n terms, so 1 plus 1 plus 1 plus 1 plus everything will be there. So you are having n terms, so that will be n, 4 into n. Okay, so now we need to apply the formula for this summation r is equal to 1 to n r. So what is that formula? Because we are dealing with summation r is equal to 1 to n f of r by n, that is equal to 5 by n. Okay, so what is the formula for this summation r is equal to 1 to n r? The formula is n into n plus 1, n into n plus 1 divided by 2. Okay, we are using that formula, and then plus 4n. Okay, and then this n and this n will get cancelled. So the value will be 5 by 2 into n plus 1 plus 4n. So this is the value for summation r is equal to 1 to n f of r by n. So now we are taking the integral now. So now integral 0 to 1 5x plus 4 into dx. Okay, dx, we are using this formula. So limit n tends to infinity 1 by n. Okay, so you write limit n tends to infinity 1 by n, and that summation value, summation r is equal to 1 to n f of r by n, that value is what? That value is 5 by 2 n plus 1 plus 4n. Okay, 4n. So now limit, we need to simplify this. Limit n tends to infinity 1 by n. So this will be 5 by 2 n plus 5 by 2 plus 4n. Okay, so we'll be having like this, and then what I'm going to do is, now I'm going to take n outside. 1 by n into, let me take n outside of this bracket, so it will be 5 by 2. If I take n outside, you will be getting 5 by 2, plus you don't have n here, so I'm going to multiply it by 1 by n, okay, plus 4. Okay, so if you multiply n inside the bracket, you will get this term. Okay, so 5 by 2 into n, 5 by 2, if you multiply n and n into 1 by n, you will get 5 by 2 alone. Okay, so that is equal to limit n tends to infinity, and this n will get cancelled. So the remaining is 5 by 2 plus 5 by 2 into 1 by n plus 4. Okay, now you apply the limit. So if you apply the limit, you will be getting the first term will be 5 by 2. Okay, so therefore integral 0 to 1 5x plus 4 into dx, that is equal to, if you apply the limit for the first term, you don't have any n, so you will be getting 5 by 2 only in the first term. Okay, and in the second term you are having n in the denominator, so 1 by infinity is 0. Okay, so the second term will be 0, and the third term you don't have any n, so simply you will put 4. Okay, simply you will put 4. Okay, so now we will add these two things, these two terms. So 5 plus 4 to are 8 by 2, so that is equal to 5 plus 8 is 13, so 13 by 2. So therefore integral 0 to 1 5x plus 4 into dx, that is equal to 13 by 2. That is the answer for the first subdivision. Clear?